Have you ever wondered how your computer manages all your files and data? Well, the answer lies in the realm of file handling. File handling is the process of creating, reading, updating, and deleting files on a computer system. It is an integral part of programming, enabling software to interact with data stored externally in files. Consider file handling as the bridge connecting your programs to the outside world. It's like the librarian of a vast digital library, managing the data with precision and order. In this video, we will be exploring key concepts related to file handling, including basic file operations, file modes, and examples in Python. We'll also touch on error handling, different file formats, and the importance of security when working with files. These concepts are foundational skills in programming and are used in tasks ranging from configuration management to data storage and log handling. Now that we've set the stage, let's dive into the basics of file handling. Before we can manipulate files, we need to understand the basic operations: opening, reading, writing, and closing files. Let's start with opening a file. This is the first step in any file operation. You see, to read or write data, a file needs to be opened first. We use functions or methods provided by the programming language to do this. Once a file is opened, it becomes accessible to the program for further operations. Next, we have reading from a file. This operation allows a program to retrieve information stored in the file. It's like picking up a book and reading the words written on the pages. The method we use to read data depends on the programming language and the format of the data we wish to retrieve. Now, we move on to writing to a file. This operation is how a program stores information for future use. It's akin to jotting down notes in a notebook for later reference. Writing to a file can involve adding new content or overwriting existing content, depending on the requirement. Finally, we come to closing a file. You might wonder why this is important. Well, once we're done with our file operations, it's vital to close the file to ensure that the resources associated with the file are released and that all changes are saved. It's like closing a book after you're done reading. Now let's talk about file modes. These are essentially the rules that dictate how a file can be interacted with. They include read mode for reading data, write mode for writing data, append mode for adding new data, and binary and text modes for differentiating between binary and text files. In a nutshell, file operations are like the basic actions we perform on a physical book. We open it, read the contents, jot down notes, and close it once we're done. And file modes? They're like the guidelines that tell us how we can interact with the book. With these basic operations, we can start interacting with files. But first, we need to understand file modes. File modes control how we interact with files. They determine whether we're reading, writing, appending, or dealing with binary data. In the sphere of file handling, file modes are akin to the director's commands on a film set. They dictate the interaction between the program and the file. Let's delve into the different file modes. First up, we have the read mode, denoted as R. This mode is like a library, where you can pick up a book and read its contents. It allows a program to retrieve data from a file. However, just as a library won't lend you a book that doesn't exist, attempting to read a non-existing file will result in an error. Next, we have the write mode, represented as W. This mode behaves like a notepad, giving you the freedom to write your thoughts. With this mode, a program can store information in a file. If the file already exists, its content will be overwritten, much like erasing a chalkboard to write something new. If the file doesn't exist, the system will create a new one, similar to opening a fresh page in your notepad. The append mode, denoted as A, is the courteous cousin of the write mode. It adds new data to the end of a file without disturbing the existing content. It's like adding a postscript to a letter. If the file doesn't exist, a new one will be created. Then we have the binary mode, B, and the text mode, T. These modes are the chameleons of file handling. They can be used in conjunction with other modes to specify the type of file we're dealing with. For instance, RB for reading binary data, or RT for reading text data. In essence, file modes are the master keys that unlock the doors to different types of file interactions. They provide us with the flexibility to choose how we want to interact with our files, whether we wish to read, write, append, or deal with binary data. Now that we understand file modes, we're ready to see them in action. Let's see how these concepts come together in Python, a popular programming language. Python offers a simple and intuitive way to handle files using built-in functions. First, let's look at how to open a file. In Python, we use the open function. This function takes two arguments, the name of the file and the mode in which the file will be opened. For example, to open a file named example.txt in read mode, we would write with open example.txt, R, as file. The with keyword is used here to automatically close the file once we're done with it. Now let's read from this file. After opening the file in read mode, we can use the read method to retrieve its content. Here is how it's done. Content =, file.read. After this line of code, the variable content holds the text from our file. But what if we want to write to a file? Well, Python makes it easy. We just need to open the file in write mode, which is denoted by do. Here's an example. With open example.txt w as file. Now we can use the write method to add content to the file. For instance, to write hello world to our file, we'd use file.write hello world. But what if we don't want to overwrite the existing content of the file? That's where the append mode comes in handy. Denoted by A, it allows us to add new data to the end of the file. Here's how we can append the text appended content to our file with open example.txt as file, followed by file.write and appended content. In each of these examples, we've seen the use of different file modes, R for reading, W for writing, and A for appending. These modes tell Python how we intend to interact with the file, and Python takes care of the rest. These examples illustrate how file handling works in practice. But what happens when things don't go as planned? File operations can encounter errors. Proper error handling ensures our programs can respond gracefully to unexpected situations. Imagine you're trying to open a file that doesn't exist, or perhaps you're attempting to write data to a file, but the disk is full. These are common issues that might crop up while handling files. So how do we deal with these? Each programming language provides mechanisms to catch and handle these errors. For instance, in Python we use try and except blocks. You try to execute your file operations in the try block. If an error occurs, instead of the program crashing, it jumps to the except block. Here you can define how the program should respond. This approach ensures that your program handles file operation errors smoothly, without breaking down in the face of adversity. Remember, a robust program is one that anticipates and handles potential issues, and file handling is no exception. Errors are part of working with files, but so are different file formats. Different file formats require different handling, and no matter the format, security is always a crucial consideration. Diving into file formats, there's a smorgasbord to choose from. Let's focus on a few common ones. Text files, denoted by the txt extension, are the simplest, storing data as plain text. CSV files, CSV, are also text-based, but they organize data into columns and rows, making them perfect for spreadsheets or databases. JSON files, JSON, on the other hand, store data in a structured, human-readable format, making them a favorite for web applications. Lastly, we have binary files, which can hold a wide variety of data, from images to executable programs. Each format has its own quirks and requirements. Text files are straightforward, but CSV files require parsing to separate data into its constituent parts. JSON files need to be decoded into a data structure that your program can understand, while binary files often demand specialized handling due to their complex nature. Now let's shift gears and talk about security, a topic that's as important as it is vast. When handling files, it's vital to consider three major aspects: file permissions, access control, and user input validation. File permissions determine who can read, write, or execute a file. Setting these correctly prevents unauthorized access and modification. Access control goes hand in hand with permissions, defining who can access what data. It's the bouncer at the door, ensuring only the right people get in. Lastly, there's user input validation. When your program takes input from a user, say a file name to open, it's essential to validate that input to prevent security vulnerabilities. For instance, a malicious user might try to trick your program into opening a system file or executing a harmful command. By validating input, you make sure your program only does what it's supposed to do. File handling is a foundational skill in programming, enabling the storage and retrieval of data persistently. While the specifics may vary between programming languages, the core concepts remain the same: